The A-37 has a very simple hydraulic system compared to any other fighter aircraft. Although barely adequate, the system is very reliable. As you can see from this slide, the hydraulic system provides power to the landing gear, inlet screens, thrust attenuators, speed brake, flaps, spoilers, nose wheel steering, and slot lip spoilers. Unlike most fighters, the flight controls are not hydraulically powered. One of the components of the 1.8-gallon hydraulic system is the reservoir, which holds the excess fluid. On each pre-flight, you should check the quantity and the pressure gauge. The amount on the sight gauge will be determined by the pressure in the accumulator. If you don't remember how to read the gauge, the instructions are printed on the service access panel. On the instrument panel, adjacent to the engine instruments, is the hydraulic pressure gauge. It is calibrated from 0 to 4,000 pounds pressure. Normal pressure and maximum pressure are marked by a green band and red line to assist reading the gauge. The hydraulic pressure is maintained between 1250 psi and 1550 psi by a pressure regulator. The accumulator previously discussed absorbs surges in the system. Downstream of the pressure regulator is a pressure relief valve, which will release hydraulic pressure if system pressure reaches 1750 psi. A cockpit indication above 1750 psi indicates failure of the relief valve. The hydraulic pump, located on the accessory gearbox of each engine, is capable of supporting the entire system. There is a slight increase in time required for operation of some components with single-engine operation. As the pilot, you have no control over the hydraulic pump. It operates whenever the engine is turning. A low hydraulic pressure indication may or may not indicate failure of the hydraulic pump. Also, one hydraulic pump could fail without any cockpit indication. To detect a single pump failure, the hydraulic pumps are checked on each flight in the following manner. The left engine is started first, and the hydraulic pressure is checked. This way, you are assured that at least the left pump works. At the end of the flight, the left engine is shut down first, and the right hydraulic pump is checked. By using this procedure, each flight may be begun, knowing that on the previous flight, both pumps were operating normally. A is correct. 1250 to 1550 psi is the normal hydraulic pressure. is correct. An indication of 1750 psi means that the relief valve has worked properly, but the pressure regulator has failed to limit the psi to 1550. C is correct. Both engines are checked using this method: left during engine start and right during engine shutdown. Now that we have talked about the hydraulic supply, we will discuss each component which uses hydraulic power. The landing gear is the most important hydraulic component of the A-37. As such, it is the only hydraulic component with a backup system, which will be discussed in a few moments. The main components of the gear system are main and nose gear, gear doors, gear handle, emergency gear T-handle, the blowdown bottle in the nose wheel well, emergency retraction system, and down and lock indicators. The pneumatic air blowdown bottle is located in the nose wheel well of the aircraft. However, a gauge indicating bottle pressure is located in the gun bay for ease of viewing during pre-flight. The gauge should read 2000 psi plus or minus 250 psi. If not, have it serviced. Less pressure could prevent a successful emergency gear lowering. On the ground, the gear is held down by over-center locks on the struts, which are held in place by hydraulic pressure. In addition, gear pins are installed when no hydraulic pressure is available. When aircraft weight is on the right main gear, the gear handle solenoid is de-energized. The solenoid will retract only when aircraft weight is taken off the right main gear or the landing gear emergency override switch is pressed. When the gear handle is raised to the up position on takeoff, a red light in the handle will illuminate until the gear is up and locked. Care should be taken not to exceed the absolute maximum gear speed of 170 knots indicated prior to the light going out. With normal pressure, gear retraction time is approximately 10 seconds. Lowering the gear takes about 8 seconds. The light in the handle will be on until the gear is completely up and locked or down and locked. Lowering the gear handle starts a sequence of events. Study this sequence. Lowering the gear handle mechanically unlocks the nose gear and nose gear doors and positions a selector valve. This hydraulically moves main gear doors and the nose gear down. Once the main gear doors are fully open, an electrical switch is tripped, which positions a hydraulic valve to drive the main gear down. As the main gear reaches the full down position, it trips another electric switch, which positions a valve to close the main gear doors. The nose doors remain open. The sequence is reversed for raising the gear. The gear warning light and audible tone will occur anytime the throttles are between idle and 60 plus or minus 3%, and the gear is not down and locked. The warning system is designed to prevent gear-up landings. A knowledge of the normal sequence is essential to determine appropriate action should a malfunction occur. In the event of hydraulic failure, the gear may be lowered by using pneumatic air pressure to blow the gear down. The gear handle must be in the down position to prevent damaging the aircraft by a 2,000-pound surge entering the reservoir. If the handle cannot be lowered, attempt lowering it using slight negative G. This should free the handle. Once the handle is down, the emergency gear lowering T-handle may be turned and pulled. Continue to hold the T-handle until the gear indicates down and locked. Once the gear has been lowered by this method, do not raise the gear. In case one or both main landing gears remain retracted when the landing gear handle is placed in the down position and hydraulic pressure indicates normal, an electrical malfunction may exist. This electrical malfunction is in the gear sequencing circuit. With the gear handle down, pull the gear sequence circuit breaker, or turn off the battery and generators for 15 seconds. Then restore power. To avoid a collision with a ground obstacle, the gear may be retracted in an emergency by simultaneously pressing the landing gear override button just to the right of the gear handle, and raising the handle to the up position. This will override the downlock solenoid and allow the gear to retract on the ground. This is a last resort procedure and should only be used if stopping distance is critical. You must have both hydraulic and electrical power to retract the gear on the ground. Keep in mind that the override button must never be used to raise the gear in flight. If the gear won't come up, leave it down and land. B is correct. With electrical failure, the gear handle solenoid will not retract, and the handle will not come up to raise the gear. B is correct. The gear handle must be placed to the down position before turning and pulling the T-handle, and not afterward. A is correct. You must have both electrical and hydraulic power for emergency gear retraction. This concludes the landing gear system. Pressing and releasing the nose wheel button engages the nose wheel steering. The nose gear steering unit is activated by movement of the rudder pedals through a mechanical linkage to the nose gear steering unit. Pressing and releasing the button the second time disengages the system. The system will also disengage automatically at takeoff, as weight is taken off the nose gear. You should, however, disengage it as soon as the rudder becomes effective on takeoff. A priority valve maintains nose wheel steering pressure while the speed brake is operating to prevent losing nose wheel steering each time the speed brake is used. If you lose nose wheel steering when extending the speed brake, a malfunction has occurred and should be reported to maintenance. As this caution points out, the button should not be held down like in some other aircraft. The steering limits are 40 degrees either side of center and 50 degrees if differential braking is used. When using differential braking, disengage the nose wheel steering to avoid